role of the CPU. And now the thing is that what's the role of the register? So the role of register, just think it at a very high level. Let's say we are doing a calculation where I am saying that, okay, A equal to 10, and let's say the variable B is equal to 20. And let's say then we are executing A plus B. So what this three instruction will do is that the A equal to 10, so that value will be stored in the register. Okay, so execution unit is something where the execution actually happen. So what will happen when the instruction A equal to 10 comes up? So thing is that what will happen is, let me just try to also explain that figure. So let's say we have, so there's a very simple code, let's say, where A is equal to 10, and let's say B equal to 20, and then let's say A equal to A plus B. Let's say this is the instruction. Okay. And now what will happen is, let's say this is the instruction, and this is something, let's say, stored in the memory. Okay. In the memory part. Okay. So now the thing is that what we do is, let's say this is the memory, and now let's say this is the CPU. So let's say this is the CPU. Okay. So in that CPU, as I told, that there are few different kind of units. So the first one is, let me just quickly draw it down. So the first one is the what was that? Control unit. Okay, control unit. The next one is let's say execution unit, and then we have register, and then we have flag. Okay. So what will happen is that the first thing, let's do it one by one. What will happen is that the control unit will fetch the first line from the memory, and it will throw that out to the execution unit. Okay. So the A equal to 10 will be fetched from the memory, and it will be from the CPU control unit. It will go to the execution unit, and where the execution will happen of A equal to 10. So what will happen is basically in the register, there will be a, let's say there is a, actually register is all made of memory. Okay. So in that register memory, the value of A will be stored. Okay. Let's say in the register actually made of multiple different kind of memory slots. One of the slot name is, let's say, EAX. Okay. EAX. So let's say the value of 10, it is stored in 10 and stored in EAX. Then what will happen the next time? The control unit will fetch B equal to 20, and this time what will happen is that this will now go to the execution unit, and this time again it will go to the register, and in the register what will happen is that we have something called as EBX register. So let's say, because so there are different kind of memory slots, we'll kind of seeing that at a very deep level. But what I'm trying to understand, trying to kind of make you understand is that now let's say the sixth one came. So the value of B will be stored in another register. Let's say the name of that memory slot is EBX. Okay. So the two values have been stored in, one is in EAX and the next one is in EBX. Now what will happen is the next part where the thing is being done is, now the control unit will fetch the next line, which is 7, which is the seventh stage, where A equal to A plus B will be kind of fetched out. Okay. And now the thing is that what will happen is that this will again kind of go to the execution unit, execution unit this time. So let's tell this one as 8. Okay. And now what will happen is that in the execution unit, the value of 10 plus 20 will be added. 10 plus 20 will be added. And then the final value, which is of 30, let's say, is again written back to the EAX register itself. To the EAX register itself. And that's how the calculation normally happens in a layman terms, one by one. And there is certain thing let's say the flag register. So flag register is something, let's say, its role will come up. Let's say one of the example can be where its role will come up. It's, let's say, let me do one thing. Okay, so what the flag register actually does is that it actually controls, let's say, in what register the memory will be stored. And one of the good example of understanding flags is, let's say, let me just quickly do it over here in a separate form. Okay, and let's say there was some kind of looping in action. Okay, let's say there was some kind of loop for, let's say, for I in range 0,5. And then there was something like a equal to a plus 1, something like that. So in that case, thing is that the role of flags will be much more kind of highlighted. What the flag will be doing is that, let's say, there will be another kind of a register which is called as ECX. And ECX is basically normally kind of used for kind of doing the looping thing or counting the stuff, how many counts will happen. So that's where the flag will kind of play its role. Okay, so overall thing is that the CPU is normally made of 4 components, which is control unit, execution unit, register unit, and flag. Okay, so this is something in a layman terms. And let's say this memory is the RAM memory. Okay, this memory is the RAM memory. Okay, now once I have discussed this, I will add one more level of sophistication. So the thing is that, let's say now the other level of sophistication is that, let's say this time I say that the CPU is a combination of all of this, not just 4 units, but it is also a combination of an extra memory. Okay, so in that case, what I mean to say is that in that case, what will happen is that we need to discuss that there will be our own RAM memory. Okay, where initially this code will be existing over here. Okay, will be existing over here. This code will be here. And then this memory, you can just tell that this is the cache memory. Okay, so what will happen is that the codes will first come from the RAM memory. And let's say the line of code is, let's say, 1,000 line of codes are there that needs to be executed. And let's say that code is in the RAM memory. So at least the first 10 lines, will be stored in the cache memory. Okay, it will be executed. And once that's done, that's where the next 10 lines on the RAM memory will be fetched and it will be stored in the cache memory. And from the cache memory, the control unit will kind of fetch the 10 lines and keep it kind of executing all this thing one by one. Okay, so this is normally how let's say the thing actually works. So in normal sense, the CPU is not just made of 4 units. It also has it also quickly, it's kind of integrated with the cache memory also. And then there are different levels of memory. So even you will be kind of encountering that it's not just RAM, and between them there are also like different levels of cache memory. Okay, cache memory. And then after this RAM, the only memory that is left out is our normal hard drive. Okay, so this is how the data actually goes to the CPU. So our code actually always be existing on the hard drive. And when that software is loaded up in the RAM memory, the code of that goes to the RAM memory. And from there, a little bit chunk by chunk, that code goes to the cache memory. And that's where the CPU execute that code one by one. But today, this is how the things look like at a very high level.